This is the world. Inspired by the humble earthworm. But how did we do it?
So for the design concept, we didn't want to do the tried and tested methods of wheels and tank tracks and legs because that's what essentially everyone does. And so in the pursuit of trying something unique, we ended up going with the way a worm moves for our chosen method of locomotion. The way we tried to achieve that, or the way we ended up achieving that, is by virtue of this mechanism, which takes a lot of inspiration from a piston, like in what you see in a car engine, but then taking the top of that engine and connecting it to two separate, completely distinct parts of the worm robot body that allows it to expand and contract. But also, thanks to the way we designed this mechanism, it's also still able to turn, despite everything being very much rigid, which allows us to then get that worm-like locomotion.
Now, given our robot's sheer size, we plan to brute force our way through the first couple of obstacles, including the doors, the ramps, etc., uneven terrain. And we have claws to help us go over the rollers and stairs. And for the payload, we plan to use the robot's arm to hold or bring the parts. Now, for the second stage, we plan to use the camera on top of the arm to scan the QR code and to use it to open the door.
So for the arm and gripper design, we decided not to overcomplicate the entire design as a whole. So inside the gripper, we're using a rack and pinion system to connect the two claws, and we're powering that using a servo motor so it can open and close. On top of the gripper, we also attached the camera so that we could move the camera up and down at will.
So how we're controlling our robot is by using a PS5 controller, and whatever inputs we press on the buttons will be sent to the microcontroller itself via the Raspberry Pi connection. And for the power electronics itself, we made an entire connection between the DC motor and also the other 8 servos we are using, and how we're controlling the current and making sure that every single servo receives its required voltage is by utilizing 5 different buck converters.
Our first main problem was weight and size. Originally, we had an outer shell on the robot that we found was too heavy, and ultimately we decided to ditch it and keep only the skeletal structure inside, which gave us more freedom to mount circuitry and the claws. The next problem we faced was a friction problem, which was the moving mechanisms were moving too roughly. So we decided to solve that by applying a layer of lubricant and graphite. The next friction problem was with the bottom TPU pads, which were hindering the movement of the robot. We solved this by decreasing the diameter of the flywheel, which gave the robot more torque and more freedom of movement.